Good morning.
Good morning, Professor.
Everything what has a starting day practically is having the ending day as well. Today is our last lecture for this semester. I hope that even in this very difficult for everyone circumstances, you were able to learn some important things for your coming math classes in the next level. Definitely. Unfortunately, at the beginning of semester, I had more ideas about what to do in our class. Usually I realize these plans all the time, but like giving you different handouts, which are very useful for you guys, but unfortunately did not happen because we again had full hands with that distance learning. I'm going to continue with the problem which I started yesterday and we did not have time to finish, but I would like to say something again. I decided not to give you another quiz, so-called in-class quiz, because we already had a few, but I think that it would be very useful if, let's say, just before your final, you can get another online quiz through Wiley Plus, where you can try to solve problems from different chapters. It is like cumulative type of the quiz. What do you think about that? Just to refresh your memory to know what you can do, what you are struggling with, and etc. This why, please, again, keep in your mind that you need to check what is posted on Wiley Plus just after few days, because your what is the date? I think, can you check? I think your finals on 20th, right?
Yes, on Wednesday.
Yes.
I'm just checking right now. Final, yeah, this is on 20th. So, and today is 15th, right?
Yeah.
Yes.
So which means after 5 days, just specifically in 2 last days before the final, please check what you have on Wiley Plus, because I am about 95% sure that I would post another cumulative type of quiz to help you to review for coming finals. Definitely what we will include in finals: properties of functions, or problems related to linear functions, quadratic functions, trigonometry. There is lots of, actually, there we have so many different problems, lots of ideas, because it can be about properties and graphs, it can be about simplification, compositions with inverse to each other functions, identities, equations, and so on and so on. And simple, actually, simplification. And again, because right now we are talking about properties and graphs of functions, there definitely I will try to include problems with limits. So this what we actually covered and what you should have material for in your notes, and in that quizzes and tests which we had on papers and which I graded and gave you back. So if you like to ask me something right away about coming final, do that right now.
Is the test going to be on Wiley Plus, or is it going to be emailed to us.
You know what? I already have two options, and I will see what would be more beneficial and for easier to approach to you and to me. And so I definitely will notify you about all details if it is coming, let's say, like an attachment to email, which I already did, actually sending you your quizzes and tests in that manner, or it will be through Wiley Plus. So I cannot exactly answer, but you need to be prepared for both options. Okay. So another thing what I wanted to talk about is if you like to know your class participation grade, you can actually email to me, and in a very short email, I will reply to you. I have practically all your um, uh, grades right now, but definitely if we have today's class, maybe some the students can get some adjustments to their grades. This is also I would like to talk about. Don't forget about your time, because our regular class, we kept the same schedule as we had at the beginning of semester. We had from 12:10 to 1, but it will be not the same time interval for your final. Your final will start at 11:10 a.m. on May 20th, and it will run until 1:40 p.m. And you know what? I decided to be at that time on Zoom, but not for entire interval, because I already actually programmed all these Zoom sessions in March, when we started using Zoom for our distance learning. And I will be there available during our regular class time. And you actually can visit me on Zoom during this time interval. This is also, I'm not obligated to be there, but I will be there. I will be there available on Zoom during that same class time which we had during semester. More questions? I already discussed the formula for calculating your overall grade. And another thing what I like to mention, I, again, every single day I'm getting tons of work-related emails, but I don't want to look really like not cooperating person in your eyes, but please do not email me about asking about your grade for final or overall grade for semester, because I will post your overall semester grade right away after I'm done with grading final, with having everyone's final grade for entire semester. And for us, I think this information is due by June the 1st. I will immediately post this on WebSmart. And I usually never wait to the end of that allowable time interval and do that in the last day. No, I try to do that as fast as I can, and usually I post these grades much before, many days before the due date. This is why you can check WebSmarts after your finals to see if your final grade is there or not. Because I don't want to look really as a bad person in your eyes, but I tell you about that in advance, even though if you send me your email and asking me about the grade for entire semester, I will be not answering that email because I will have full hands of work related tasks. So please be understandable. So this is about that. But I will keep all these records and everything for at least 1 year after our semester. And I hope that finally we can come to the normal teaching process. I'm talking about face-to-face classes using our campus. And at any time during this 1 year period, you can ask me to explain everything about calculations. You can make an appointment with me. You can come and we will talk about everything. And when I talk about 1 year period, I mean discussing everything what is related to your particular semester and your class. Because after 1 year, we do not keep this documentation. But if you need to come and talk to me even after this 1 year period, you are absolutely welcome to come and visit me, and it will be a big pleasure for me to communicate with anyone. And I would like to say again, even though we faced so many problems this semester, I need to admit that it was a big pleasure for me to teach all of you. And again, I hope that what you learned in my class can help you in your future math classes. So thank you for being in my class. And I hope, I'm just hoping that in your life, I was not your worst math professor. Thank you. So can I start solving problem right now?
Yes.
Yeah.
Okay, let me remind you where we stopped. Just 1 second. It was a rational function. I call this like example number 1. And this where we stopped. I will briefly go over these steps which we already had on
What page is
our,
this?
excuse me?
What page is this on? What page is this on, Professor?
This is not on the page. I heard, I am just
okay.
doing, can you see I wrote example number 1.
Oh yeah, I see. Thank you.
Yeah, it is not from the textbook, but textbook has many similar problems. This is a rational function. And we factored the denominator because we tried to find so-called excluded values. We found them. There were 2 numbers, -3 and -2, which cannot be used as x values for this particular function. This is why we excluded them both from R to get our domain for this function. After that, we decided to see if we have x-intercept, and we do not have x-intercept for this particular function. After, to get x-intercept, you need to make y or f at x equal to 0 and solve this as an equation. This equation did not have a solution. This is why we did not have x-intercept. When you need to look for y-intercept, you need to make x equal to 0 and plug it into your formula for that function. In other words, you are finding the value of that function for x equal to 0, and we found that y-intercept, it is 0,16. And after that, we were talking about this function possibly being even or odd. It cannot be even nor odd, because if your domain is not symmetric with respect to the origin, function cannot be even nor odd. If we had 2 pairs of bad points which are symmetric to each other, let's say here we have that number -3, and let's say if we had beside that +3 as a bad number which we exclude from R, or let's say we have -2, and for -2 we have a symmetric bad point which is +2. In other words, what I'm saying, if our domain is set R except +3 and -3, positive 2 and negative 2, domain is symmetric with respect to the origin. At that case, you need to take the next step. You need to check if f at minus x equals to f at x. If it is working, function is even. If it is not working, you need to go to the other step. You need to check if f at minus x equals negative f at x. If it works, it is an odd function. But if it is also not working, your function is neither even nor odd. This is why when your domain is symmetric with respect to the origin, you have a longer process to see if the function is even or odd. If from the beginning you have domain of the function not symmetric with respect to the origin, don't continue with that process. It is the shortest way to get that answer. No, function is neither. It cannot be even or odd. Do you understand what I'm talking about?
Yes.
Yes.
Okay. Okay, so what I'm going to do right now in the fifth step, I will investigate so-called long run behavior of this function. Okay, if I calculate this limit, x is approaching positive or negative infinity and of that function, and the result of that limit will be equal to the certain number, constant number. In this case, that function will have a horizontal asymptote where y equal to that number, which is equal to that limit. If we are getting an answer for this limit, positive infinity or negative infinity, we do not have horizontal asymptote. Let's do that. I will try actually to combine these two in one piece to see what is going on. This is why I'm writing limit sign x approaching plus minus infinity of y. And you know what? I will be actually using right now, even not simplified version, because it is a limit, because we will see if we have here any uncertainty. X approaching positive, negative infinity, 1 over x squared plus 5x plus 6. And let's pretend that we are plugging, instead of x values, we are plugging infinities. It is a fraction. On the top, we have one constant number. Downstairs, we have x squared. Is it infinity squared, which is infinity?
Yes.
Yes.
And this is actually dominating power, right? Because it has a square. Why I'm talking about? Because if I have that square, if I'm squaring positive infinity, squaring, or I'm squaring negative infinity, result will be positive infinity, right?
Yes.
Guys?
Yes.
And the rate of reaching infinities, because it is x squared, is very high. It is approaching much faster infinities when comparable with x in the first power. Do you agree with me that first power is much slower in its rate reaching infinities than x squared or x cubed or x to the fourth power? So which means that x squared is like a dominating piece. We have 5x, which if x is reaching positive infinity will be positive infinity. But if it is reaching negative infinity, negative 5x will be reaching negative infinity. But it is related to x in the first power. So that x squared is more dominating infinity. So in this case, if we have positive infinity related to the x squared and negative infinity related to x in the first power, result will be positive infinity. But if x is approaching positive infinity, definitely with x squared, that is all the time positive infinity plus another, it is infinity. And finally, we have that poor 6 at the end. it can be completely ignored. So what do we have here? We have here 1 over infinity. Is it? I wrote here on the side. Is it correct?
Yes.
Yes.
So if you have that kind of fraction, on the top you have 1, on the bottom you have number which constantly increases going toward positive infinity. What would be the limit of that fraction?
0.
Definitely, you are absolutely correct. The limit is equal to 0. This is your long run behavior investigation. And what can you say immediately? You have here a horizontal asymptote. Horizontal asymptote is y equals 0. This is your horizontal asymptote. Yes, we have a horizontal asymptote. Okay, but now I will talk about something different. Because in our domain, we did not have set R. We had set R except 2 bad numbers, -3 and -2. What can we say about that? Because there is a big chance of having vertical asymptotes. And you know what we talk about these kind of situations when we have our rational functions specifically and R except certain numbers. We are talking about so-called short run behavior. So we already talked about long run behavior when we had limits x approaching positive infinity or negative infinity. When we have exceptions from R to get domain, we can talk about short run behavior of the function. And what can we do here? We can also work with limits of this y. And I'm going to approach right now this x to each of these bad numbers. So we can start with -3, but how x can be approaching to that number? Can it be coming from the left side or from the right side to -3? Guys,
Yes.
I ask everyone a question. If we have -3, which has open circle, but all other numbers around -3 are in our domain, can I get some values which will be coming closer and closer to -3, but not reaching -3 from the right side?
Yes.
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 Does it mean that we can talk about so-called right limit? In this case, when you write down limit x is approaching -3, write with -3. Can you please write this symbol? Can you see I wrote it is approaching -3 and small plus on the place where we usually write exponents. Can you see?
Yeah.
Yes.
It means right limit. It means, yes, x is approaching that -3, but it stays greater than 3 all the time. Do you understand that? Let's see what is going on. In this case, actually, I will be using the factored version for the denominator. It will be easier. X is approaching -3 with plus. And I have 1 over x plus 2, x plus 3. Only one of these parentheses is not friendly with -3 because when we have x plus 2, I do not have any problems actually plugging this -3 into that parenthesis. And look what I'm going to do. I'm right now investigating that situation. Don't forget, x is coming closer to -3. It stays greater than 3. In this case, what can you say about x plus 2? Can I say that x plus 2, if you plug -3, will be reaching -1?
Yeah.
Yes.
So, and I have no problems writing that. I'm moving to the second spot. X plus 3. If x is coming closer and closer to negative 3, is it true that it is actually, if it reaches that, it will be 0? I can say that when x is approaching negative 3, x plus 3 is moving closer and closer and closer to negative 3.
Yes.
To 0, I really apologize. Yes?
Yeah.
Yeah.
But don't forget, here, x is approaching negative 3 from the right side. So which means it stays greater than negative 3. What kind of numbers are greater than negative 3? Is it true that it will be, let's say, negative 2.5,
Yeah.
Yes.
negative 2,
Yeah.
Mhm.
negative 1,
Yes.
Yeah.
negative 0.5,
Mhm.
negative 0.3? They are all greater numbers than negative 3. If you plug these numbers into that parenthesis, are you going to get positive number or negative? Adding 3.
Positive.
Positive, right?
Yes.
So which
Yeah.
means you are writing down that it is approaching 0 from the right. Look what I wrote down. I wrote down 1 over negative 1 times positive 0. When I say positive 0, I do not mean that it should be 0. I mean that it is number close to 0, but greater than 0, positive number. Do you understand what we mean?
Yeah.
Yes.
So what do I have on the bottom? If you multiply negative by positive, is it negative?
Yes.
Yeah.
So which means downstairs, I will, in this case, for that situation, I will get so-called negative 0. Is that correct?
Yes.
Yeah.
If you divide positive number by negative, what about your result? Is it negative?
Yeah.
Yes.
So in the limit, answer here will be negative infinity. Negative infinity. And yes, I already know that from the right side coming closer and closer to negative 3, I will have here a vertical asymptote. From the right side, I will have a vertical asymptote. So, which means coming closer to negative 3, graph should go down, more down and more down without any barriers. In the same way now, but I will be doing that much quicker, I will be now investigating same thing, only approaching negative 3 from the left. So, and I am going to do this search in the absolutely same manner. So, same thing, this second parenthesis, x plus 3 is not friendly with negative 3, but I will be doing what I did before. Don't forget, x approaching negative 3 from the left means coming closer and closer to negative 3, but staying less than 3 all the time. So which means it can be negative 7, negative 6, negative 5, negative 4, negative 4.5, negative 4.75, negative 4.9, etc. Do you understand that?
Yeah.
Yes.
Okay. So again, first x plus 2, it is absolutely normal that I just will plug this number and it will be negative 1. There is no problem. But if you look at this x plus 3 piece and you pretend that it is coming closer to negative 3, but stays actually less than negative 3 all the time, can I say that this sum x plus 3 will be approaching 0 from the left, staying negative number all the time?
Yes.
What
Yeah.
what do you see downstairs? You see negative 1 multiplied by negative 0. Is it going to be positive 0?
Yeah.
Yes.
If you divide positive by positive,
It's
are
positive.
you going to
Positive
get
infinity.
positive now infinity?
Yes.
Yeah.
Can you see from both sides approaching to -3, we have a vertical asymptote. Only when it is approaching -3 from the right, graph will be going down. When you are approaching -3 from the left, piece of the graph will be approaching positive infinity. In the same exactly manner, we will be now investigating same limit when x is approaching negative, excuse me, I said negative or positive 2. No, I really apologize. What I'm talking about, -2 from the right. I wanted to say from the right says that, and limit x approaching -2 from the left. So, and I'm doing the same type of investigation, only now x is approaching -2 from the right of that fraction. And this down, and limit x is approaching -2 from the left. I actually wrote both of them right now. And we will calculate it right now.
Can you move it down a little bit, please? Thank you.
And now let's investigate each of these two cases. Only this part, x plus 2, is quite dangerous. X plus 3, you just can plug there, x equal to -2. -2 plus 3, is it 1?
Yeah.
Yes.
Okay. Now, let's talk about this piece. Again, x is approaching -2 from the right, which means staying greater than this number all the time. What kind of numbers? Can I say if it is -2 close to that from the right, let's say -1.5,
Yeah.
Yes.
-1,
Yeah.
Yes.
0.
Yeah.
I even can't even ignore 1, 2, all these positive numbers. I'm talking about these numbers close to that. Let's say if you are plugging -1.5, is it going to be positive? 0.
Yeah.
Yes.
So write it down. It is 1 over +0 times 1. +0 times another positive number will be positive number. So downstairs, you have 1 over +0, right?
Yes.
Yeah.
And we already know the answer will be infinity. This is additional verification that here also we will have a vertical asymptote. And in the same manner, let's move to that piece when x is approaching -2 from the left, which means staying less than -2 all the time. So it is, let's say, -2.5, -3, -4, -5, etc., right? Guys,
Yes.
if
Yeah.
you plug it, can we say that it will be limit equal to -0 for that x plus 2?
Yes.
And look what you have now. What is the meaning of that? It means that you need to multiply any negative number which is very close to 0 by 1, which is positive. Are you going to get -0?
Yes.
In other words, 0 with minus. If you divide positive number by negative, we all the time get negative. So it will be negative infinity. Agree?
Yes.
Excellent. Now, let's summarize. If I were you, I would immediately write vertical asymptotes. What kind of vertical asymptotes? X is equal to -2 and x is equal to -3. So x is equal to -2 and x is equal to -3. What I'm going to do now, I'm going to sketch graph right now, possible graph. And after I have a graph, I will talk about the range. Please sketch X and Y axis. Don't forget your domain here is set R except -3 and -2. Show that numbers So x-axis, y-axis through -2 and through -3. Sketch 2 dashed. Please don't do them solid because asymptotes are not part of the graph itself. There are restrictions for that graph. You will see right now what I'm doing. Just 1 second. Are you done?
Yeah.
Yes.
Okay, and now I'm going to use these properties to do the work. First of all, I will look at the numbers on the left side from -3. What do I see here? This y, I need to look at the long run when x is approaching -infinity. And what do I see here? When it is approaching -infinity, it is limit equal to 0, which means when x is going to the left, the graph should be approaching y equal to 0, in other words, x-axis. At the same time, keeping in our mind the short run behavior, when x is approaching -3 from the left, the a limit equal to +infinity. And on this interval, we do not have any x-intercept. This function does not have any x-intercept. So I already know that this will be certain type of the graph, which will be completely above the x-axis. And I already sketched that piece right here. Now, I am going to talk about the numbers on the right side from -2, another asymptote. And after that, I will talk about right in between. What do we have here? We don't have x-intercepts. We talked about that. But can you see? We have a y-intercept. Y-intercept we have for x equal to 0. For x equal to 0, y is equal to 1/6. Can you see that?
Yeah.
I'm going to show that point. 1/6, it is very difficult, it's quite a small number, but let's say I call one point like 1/6. This is 1/6 right here. I show this on y-axis. Now, what I'm now looking at, I will look at what is happening with long run when x is approaching +infinity. Can you see it is also says that this limit was equal to 0?
Yes.
X approaching +infinity. So, which means it will be crossing that point, and it will, and there is no x-intercept here. So look what I did. I have here a small piece that now I'm looking at the short run behavior when x is approaching -2 from the right. When x is approaching -2 from the right, limit is +infinity. So voila, I have another piece of that graph. So far, so good?
Yes.
Yeah.
And you know what? You now like to see what is going on between -3 and -2. So you are looking at the limit when x is approaching 3 from the right and x approaching -2 from the left. When it is approaching -2 from the left, limit is equal to -infinity. When it is approaching a -3 from the right, limit is also is -infinity. So practically you have that kind of thing like small parabola. If you like to know some other values, because we are talking about possible graphs, you can find the value of that function when x is equal to -2.5, just plugging here in this parenthesis or plugging this into version with x squared plus 5x plus 6. Let's say negative 2.5. Let's plug this when it is factored version. Negative 2.5 plus 2. Is it negative half?
Yeah.
Yes.
When you plug into second, negative 2.5 plus 3, is it positive half?
Yes.
Yes.
Is it 1/4?
Yeah.
Mm-hmm.
So practically, at that point in the middle, you have that kind of graph. And look what I did. This is your possible graph for that function, and quite precise graph. And now, having all these pieces in front of my eyes, I can finish that. So this was already part 7 in our search. And now I can finish with this part 8, because when I see that graph in front of my eyes, I easily can assume that the range of this function, you can see all pieces, or from the top or from the bottom, are quite close to y-axis, to x-axis, but they do not touch it and do not cross because we don't have x-intercepts, which means the range here is set R except 0. And I'm completely, absolutely done with everything right here. Definitely in the calculus class, when you are equipped by derivatives, you can get more information about maximums, minimums, and you can actually get other properties as well, but points of, let's say, of inflections, intervals of increase, decrease, and everything here we also can describe. But when you are equipped by derivatives, you can get much more precise information about end graph and behavior and graph of the function and properties. But so far, for our level, it is absolutely good enough what we just did. Did you understand the entire process?
Yes. Makes sense.
Guys, one more time, look at this graph. We got this graph after we investigated all these properties of that function. So basically, short-run behavior, long-run behavior on the function they are all very important. And you are using short-run behavior only if you have not R set of all real numbers as your domain. If you have domain equal to set R, you can just use long run behavior to get some properties related to existence or non-existence of horizontal asymptotes. But short-run behavior will tell you if the function has vertical asymptotes or not. Again, if you are approaching x to one or the other bad number and you are getting result of that limit equal to the fixed number, you have that asymptote, vertical asymptote. If for the long run behavior, you are calculating limit of the function when x is approaching positive infinity or negative infinity. And if calculating this limit, you are getting fixed number, not infinities, fixed number, you have a horizontal asymptote. Can I, with your permission, move to other problems?
Yes.
Yeah.
I'd
Yeah.
like to quickly solve some problems now from the textbook on page 462. 462. And this is about limits. It says, evaluate the limits in exercises 17 through 20. Why I'm doing that? Because as you understand, in short run, long run, we are using limits. So limit number 17, page number 462, x approaching positive infinity. What do we have here? 2x negative first power plus 4. This is that problem. This is the limit of the sum. Limit of the sum equals to the sum of limits. This why it will be limit of the first addend, which is 2 times 1 over x, plus limit of 4, x is approaching infinity. Limit of 4 is 4 because limit of any constant is equal to that constant. 2 times 1 over x is a product. Limit of any product equals to limit of one component times limit of another component. But one component is a constant, it is 2. Limit of 2 is 2, which means from any limit, we can take out the coefficient. So it will be limit x is approaching positive infinity of 1 over x plus 4. What would be the limit of 1 over infinity, guys?
Professor, isn't it 2x to the power of negative 3?
Is it negative 3?
Yeah.
Yeah.
Okay, I honestly I did not see that with my glasses. Okay, so let's write x cubed. This is not big difference, only in the power. I really apologize making that mistake. Can you change it for negative 3 and after that 1 over x cubed, 1 over x cubed? So even it is faster actually because infinity to the cube, oh my God, this is crazy infinity. So what happens with that fraction when you have 1 and infinity with crazy speed on the bottom? Is it reaching 0?
Yeah.
Yes.
So the limit is 0, so it will be 2 times 0 plus 4. Is it 4 here? An answer.
Yeah.
Yeah.
Yes.
Okay, let's quickly do these problems. Okay, number, let's say 19. Limit x is approaching infinity, but this is different function, 4x plus 3x squared. Pretend that you are plugging these numbers because you need to check if you have an uncertainty or not. In the first problem, we did not have uncertainties. This is why we started using that actually theorems. What do you see here under the limit sign? Is it a rational function?
Yes.
Does it have any uncertainty?
Yeah.
What kind?
Infinity over infinity.
Absolutely correct, Lorraine. Infinity over infinity. Did we deal with that type of problems?
Yes.
What would you recommend here to do?
Divide by the highest power.
Divided by x squared.
Absolutely good idea. 4x over x squared will be 4 over x. 3x squared divided by x squared will release that 3. 4x squared divided by x squared, 4 is released, and 3x over x squared is 3 over x. This is what I have. And now, actually, it is the limit of the top over limit of the bottom. On the top, do we have a sum?
Yeah.
What would
Yeah.
be the limit of 3? Is it 3?
3,
Mhm.
yeah.
Yeah.
And limit of 4 is 4, right?
Yes.
Yeah.
But what about limit of 4 over x when x is approaching positive infinity? Is it 0?
0. Yeah.
0.
And downstairs, for the same reason, it is also 0, right?
Yeah.
Mhm.
So this what you are getting. Is it answer 3/4?
Yes.
Yeah.
Yeah.
That's it. And finally, I like honestly to solve problem number 18. Let me, oops, I need to limit, please. And first check if I copy correctly because these symbols, I broke my current glasses. This is my old pair. And with this quarantine, I struggle because I need to take this to the shop where they can fix my current glasses. That's why instead of -3, I have -1. Okay, so this is, I hope I copied correctly.
Yes, that's right.
Mm-hmm.
Okay, so what do we have here? Limit x is approaching infinity of the sum, right?
Yeah.
Yes.
So I do not see here uncertainties because I can apply right away. And here, what do I see? I see here 3 as a constant coefficient. I see here 5 like a constant coefficient. And I see here 7 as a constant, right?
Yeah.
Yeah.
So
Yes.
it will be 3 times limit. So I'm skipping some small steps. 1 over x squared plus 5 times limit. And I hope you understand why I'm doing that, because we all the time can take out of limit sign constant coefficients. Plus limit of 7, x is approaching infinity. Can you see? I split that in details, which you can see. Correct?
Yes.
Yeah.
Yes.
Now, 3 times that limit. What is the value of that limit?
0.
Accepted. 5 times, what is the value of that limit? Is it infinity?
Yeah.
Yes.
Yeah.
5 times infinity, definitely it is infinity. Limit of 7, is it 7?
Yeah.
Yeah.
So practically you have 3 times 0, which is 0. 5 times infinity, it is infinity. Plus 7, it is 7, right?
Yes.
What
Yes.
would be the answer here?
Infinity.
Infinity.
Accepted, because you are absolutely correct. Answer here is infinity. Did you understand?
Yeah.
Yeah.
Yes.
Thank you very much. Can I right now quickly check attendance? Okay. Yes. Today is 15th. Andrew, Tima, Lorraine,
Here.
here, Lynn,
Here.
Juanita, Yuran,
Here.
Gabriel,
Here.
Divina,
Here.
okay, Chantal,
Here.
okay, Gongsi,
Here.
Kyle,
Here.
Matthew,
Here.
Jillian,
Here.
Nathan,
Here.
and Alejandro. Alejandro,
Here.
okay. Again, guys, it was big pleasure for me to educate all of you. If we go back to the normal life, you are absolutely welcome to come and visit me and share with me what actually you like to share. And I really will be extremely happy to see all of you taking the final and getting very nice, attractive grade. And again, I hope that you learn quite important things reviewing old topics or getting new ideas in this class. So today is our class and I wish you the best. One thing what I really like to ask you is, would you like to ask me to upload that video on YouTube and send you a link, or it is not a necessity?
You can send it to us. That'd be good.
It will be good. Yes, I will do that for sure. I promise.
Professor, I got one more question. How long will the exam be? Like, how many questions?
You know what? It will be not more than about 20 problems.
Oh, okay.
I never offer 10 miles long finals.
Okay. Thank you.
Maybe it will be even less than 20.
Okay.
More questions? As you understand, I will be not having any more our Zoom sessions at the scheduled time because today is the last day for lectures. But, and I'm not obligated to do that, but I will do that during your final, I will be on Zoom as I am today during our class time. Not for entire time interval, because time interval for you will be from 11:10 to 1:40. They understand that because I don't want to interrupt or to do something. So because you need to work with, definitely I will be controlling you guys all the time, what is going on during the final. But I will be available to you if in the process you like to visit me on the Zoom, using Zoom. I will be available from 12:10 to 1. Is it clear to everyone?
Yes.
Yeah.
Yeah.
And again, I wish you really good luck with my math final. And I'm not extremely selfish. Definitely, I'm more concerned about math final. But I wish you good luck with all your finals. You went through very difficult time. I'm very sympathetic because it is not really easy to be a student. I had been a student for quite a long period of time. I was not born like a math professor. I perfectly know how difficult it can be. And again, this why actually in my classes I have in the calculation process for formulas, I have class participation grade to help my students to actually somehow improve their overall grade for semester. And I wish you good luck in your life. Stay safe, healthy, try to go as high as you can in educational process, because if you are healthy and you are educated, you definitely can achieve really good goals in your life. Can I finish my last lesson?
Yeah.
Yes.
Yes.
Again, everyone have a nice, beautiful day. And again, I wish you the best.
You
Goodbye.
too, Dr. K. Thank you.
Bye, Professor.
Yeah.
Bye. Thank you.
Yes. Okay, guys. Goodbye.